Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question 23 on our Grade 7 2013 Gauss competition. In the right angle triangle PQR, PQ is equal to QR. PQ, QR, there we go. So it's a right angled isosceles triangle. The segments QS, TU, VW are perpendicular to PR. So these ones are all perpendicular to PR, and then STUV are perpendicular to QR. So there they are, as shown. Okay. What fraction of PQR is shaded? So we've got this one here and this one here. Okay, what can we do? And the trick for this question is relying on a nice little relationship. So if it's an isosceles right angle triangle, these two angles, the non-right angles, must be the same. They're both going to be 45s. Okay? Then if I take the vertex here, the corner opposite the hypotenuse, and I drop a perpendicular line, well, that's a right angle. We still got this 45 here, so we must have split this into 45s. And so now these are isosceles right angle triangles as well. And same down here. And so you do it again, you're splitting into more isosceles right angle triangles. And so this sort of relationship can help us out. So now let's draw a bigger version of this and be a bit more careful with what's going on. But that's the basic idea, is that, all right, you drop a perpendicular, you're going to get another isosceles right angle triangle. Okay, so there's a bigger copy. We got P, Q, R here. And we drop S. Actually, you know what? This doesn't look isosceles right angled enough for me. There we go. That's a little bit better. So you drop S there, and then you'll drop another perpendicular there. But when we're doing it, I probably should have left my original picture up. When we do that, you get smaller isosceles right angle triangles, but because these two sides are the same, the ones I've got dashed, and then these two sides are the same, what you see is you've actually split the whole thing just in half. So this triangle here is half of the big triangle, okay? And it's the same as, these triangles are the same, they're both half of the big triangle. And then if you drop another perpendicular, you've split this in half. Okay? So what I'm going to do is I'm going to say, all right, we want a fraction of the total area. Let's call the original triangle, let's say it has an area of A. Then now, if I split it in half, each of these halves has an area of 1/2 A, right? Now, if I drop another perpendicular down, I split that 1/2 A into 1/4 A's. Then we split again. This 1/4 A gets split in half. It's a quarter of the total area. Now it's split into 1/8 of the total area. Okay? Then we do it again, and that 1/8 of an area that was down here splits into 2 different 1/16 of an area. And then I think we do it one more time. And then these 1/16 of an area split into 32nds. So that's 1/32 of the total area. Right? So that's S, then T, then U, then V, then W. Let's just make sure I got everything right. Yep. And now which ones are shaded in? Well, this one here, that's an 1/8 of the area. And this one down here, that's a 32nd of the area. So what fraction of the total area is shaded in? We don't actually care what the original area was. We know an 1/8 of the area plus a 32nd of the area out of the total area is shaded in. We don't need the A. An 1/8 plus a 32nd, that's 4 32nds plus 1 32nd. That's 5 32nds. So 5 out of 32. That's the fraction of the total area. And where's that? That's going to be D. So we bubble in D. So the key to doing this question here or doing it at least the way I did it, was realizing, oh, when you do this drop a perpendicular thing to an isosceles right angle triangle, you get smaller isosceles right angle triangles. But more than that, the second fact we had to use was that it splits it nicely in half. So as we split, we just get smaller and smaller and smaller fractions of the area, then figure out which ones you needed, add them up, and you're done. Okay? If it were a more complex question, we could have said, all right, now let's split everything all up into 30 seconds by doing this process everywhere. Okay? And you would have gotten 32 of these smaller areas. Yeah. And then you could have just picked and chosen which ones were shaded in. And other questions do things like that. But this was nice. The two blue triangles were already highlighted, or were already sort of nice and created for us. So it all worked out quite nicely. We got our answer of D. Okay. So that's it for me in this video. Let's get a fresh sheet of paper here in anticipation of question number 25. We are nearing the end of the paper. It's been a nice paper so far. If you ever have another way to do a question, by the way, feel free to leave a comment down below. And if you're enjoying the paper so far, or just in general the content, feel free to subscribe or like, but no pressure at all. And I'll see you for more math next time.